Welcome to 2.2, the decimal system. We're going to talk about the place value of our decimal point and all the numbers within a number. Our decimal point goes after the ones place value. We only have one ones place value. And then to the left, it becomes increasingly bigger by powers of 10, so tens, hundreds, thousands, 10,000s, and so on. And then to the right of the decimal place is all part of a whole. And to the right would be only one ones place. So the next would be tenths, hundredths, thousandths, 10,000ths, and so on and so forth. So in your place value system, you can see obviously 1, 10, 100, tenths, hundredths, thousandths. And here you can see it in a version of powers of 10. You remember 10 to the 0 power always equals, any number to the 0 power always equals 1. So then we have 10 to the first power, which is 10. 10 to the second power, 10 times 10, does in fact equal 100. Negative integers, actually, people often think that a negative integer makes it a negative number. But no, it just makes it a really small number. So 10 to the negative 1 is actually 1 over 10 to the first, which is 1/10. And 10 to the negative 2, if you follow the pattern, is actually 1 over 10 to the second, so that's 1 over 100, 1/100th. 10 to the negative 3 is 1 over 10 to the third, which is 1 over 1,000, 1,000th. So now we're going to try example 1 and 2, where we're going to use this number. And thinking about how we say this correctly, do we say this is 408.61 Nakamu radio station? Or do we say that this number is 408 and 61 hundredths? Yes, that is the correct way of saying it. So the question is, name the value of the digit 6 in the number. Is the 6 worth 6? No, it's one place after the decimal point, so it is 6/10. And we are going to write that as 6/10. So the value of that 6, the digit, is actually less than 1 whole. All right, number 2, write an expanded form using exponents by writing the sum of multiples of powers of 10. Expanded notation. So basically, let's take this number and expand it. So I'm going to start with saying that I have 400 plus, because the 4 is in the hundreds place, so I have 4 hundreds. I have 0 tens. A little weird, but I'm going to write out the 0 tens. I have 8 ones. I have 6 tenths. And I have 1 hundredth. All right, so this would be expanded form, but they're asking for it with multiples of powers of 10. So I want to think about, how do I write that 400 as a multiple of a power of 10? Well, it's in the hundreds, so hundreds is 10 to the second. So I'm going to write it as 4 times 10 to the second. Plus, I have 0. I'm going to put that in parentheses also, times 10 to the first. And I have the 8, which is in the place value of the ones place value, right in front of the decimal point, so that's in the ones place value, so that is 10 to the 0. And I have the 6, which is in the place value of the 10th place, so that is 1 over 10 to the first. And my last digit, which is the 1, it is in the place value of the hundredths, so it is going to be 1 times 1 over 10 to the second. And this is how you would write this out in expanded notation using multiples of the powers of 10. All right, number 3. Compare least to greatest 208, let's see, tenths, hundredths, thousandths, 208 thousandths, 208 10,000ths, and 2/10. So this can get really confusing. One option for the 208 thousandths versus 10 thousandths, you could think about, well, what pieces are bigger, thousandths or 10 thousandths? Well, if I take a cookie and I cut it into 1,000 pieces, they're all pretty small pieces. But if I cut it into 10,000 pieces, they're really small. So this one's smaller than this one. One way of thinking about it. The other is to just add the same amount of place values. So have the same amount of decimal points. So if we were to add one more zero in here, then we'd have 4 decimal places. Remember, you can always add more zeros to the right of the decimal, and that doesn't change the value of it, because 2/10 is the same as 20 hundredths, which is the same as 200 thousandths, and one more place value, 10 thousandths. So now they're all actually written in 10,000, so you could compare them that way. 2,000, 208, 2,080. And you can compare them all in 10 thousandths. So that's another way of solving it, and you can already hear it. This is the smallest, next, and biggest. The last way is just go for one place value at a time. Okay, none of them have a ones place value. It's all a 0. So then you go to the tenths. Well, 2/10, 0/10, 2/10. So this number is definitely my smallest, 0.0208. So then, because it has a smaller than a smallest number in the 10th place value. So we've already got this one. So next we have this number or this number. They both have a 2 into the 10th place, so we look to the next digit. Hundredths are the same size. Next place value, 8 versus 0. Well, which one's smaller if we're going least to greatest? A 0 is smaller. So the next digit is, or the next number is 0.2. And get rid of that one, we have one answer left, 0.208. Thank you so much for listening. Welcome to the decimal system. Whoa, whoa, whoa.